We're still in Unit 3, and the next section is equations as functions. So this corresponds to homework 3.3, I believe. So follow along in your notes as we talk about this. Now, the first thing I wanted to tell you is that this is rich in vocabulary. So it is imperative that you know what a function is, what an ordered pair is, what mapping is, what graphing is, because I'm going to be throwing those words at you. So it is imperative that you really have a picture of what I'm talking about. So the first one is functions, and remember what function is. It's a special relation, and a relation is any set of ordered pairs. So a function is a super special relation because there's only one value of x can be paired with y. And functions can also be represented by an equation or a rule. And an equation, we already know it has to have an equal sign in it, right? So the equation will generate ordered pairs by taking an input that results in a certain output. The graph of an equation is the set of all its ordered pairs, which often forms a line or a curve that we will see. So remember, we can get a whole bunch of ordered pairs, and from those ordered pairs, we can graph it. So what this is saying is that when we have an equation, we can make an input, it has an output, and when you have an input and output, those are ordered pairs, and we can graph those ordered pairs, and when we graph them, they typically result in a line or a curve. Okay? So, here is example of functions. Here's what I want you to think about. You think about a function like a machine. You put in a certain input, it's a computer, this is, it computes it, and then it's going to spit out an output. The x value is called the independent variable, which we already talked about it. Independent variable because you picked it. And the y value is called the dependent variable because it depends on what's going on with x. So that's what the function machine looks like. So here's what I want you to think about. When you have, number one, think about this as the function machine. Here's my input. So if you were to plug in -5 for x, here's my function machine, and it's going to spit out an output. So when you plug in -5 and evaluate it, -5 plus 4, that's a -1. So if I drew my function machine over here, okay, so let's say this is my function machine. And inside it's x plus 4, okay? So my x value goes in, and then it spits out my y value. So if I plug in a -5 here, -5 plus 4 spits out a -1. If I plug in a -4 here, -4 plus 4 spits out a 0. If I plug in -2 into my machine, -2 plus 4 is a +2. And if I plug in a 0, it's going to spit out a 4. And so this creates my ordered pairs. Remember, they're ordered pairs, but I set it to a table. And so now I can graph this table. And I can graph when x is -5, my value is -1. When x was a -4, my value is a 0. When x was a -2, my value is a 2. And when x was a 0, my value is a 4. So now I have these points. And because it's an equation, it could go on infinitely. I could figure out what happens when x is 1,000. What's my output? What happens when x is -1,000? What's my output? So when you have an equation, this is going to extend forever because that equation never has to stop. So what you need to do when you have an equation and a function, you need to extend this line forever. Here's how I know if you watch my video. When you have a graph, you need a couple things. You need a straight edge. A straight edge can be a ruler, a sheet of paper, something that makes this line straight. So when I'm grading homework and when I'm looking at your work, I'm making sure, one, do you have a straight line? Number two, I need your line to go through the quadrants. I don't want it stopping right here. I want you to be proud of this line. You got to carry through the quadrants, and you must have an arrow on both ends because that tells the reader you've got this function that extends infinite in both directions. So remember when we did domain and range of continuous graphs? This is the same thing. It would be all real numbers. Okay, so all we're doing here is we're really just evaluating. So if we've been evaluating since the beginning of school. So let's do, I'll do a few of these examples for you. Number 3, if x is negative 2, 3 times negative 2 is a negative 6, right? So what you can do is you can do 3 and then plug them in. When x is negative 1, my y value is negative 3. Then I can erase. When x is 0, y is 0. And erase. And then I can do it again. When x is 1, my value is 3. And then I plot my points. Negative 2, negative 6. When x is negative 1, it's negative 3. When x is 0, it's 0. When x is 1, y is 3. And then I continue my line infinite with a straight edge, infinite in both directions. Okay? All right, let's take a look at number 5. When x is negative 3. Now remember from the beginning of the year, most important rule in algebra, put parentheses around those negatives. So if I were to expand this, I would have negative, because I'm going to switch out this x value. It's going to be a different couple of different things. So when x is negative 3, I have a negative and a negative is positive 3. 3 plus 1 is 4. Okay? And now I'm going to switch it out to another value of x. What happens when it's negative 1? So this is y equals. So when I spit in negative 1, a negative times negative is positive 1. 1 plus 1 is 2. When I put in a 0, 0 plus 1 is 1. When I plug in a 4, a negative 4 plus 1 is a negative 3. So does everybody see how I'm filling out that table? Just evaluating like I do all the time. So now I plug in my points, negative 3 and 4. When x is negative 1, y is 2. When x is 0, y is 1. And when x is 4, y is negative 3. So we'll notice that line, infinite in both directions, and arrow on both ends. Okay. We use a lot of vocabulary for x values. We said that my x values was my independent variable. We have also said that all my x value is domain. So x value can be domain, it can be independent variable, it can be input. So do you see how many times? So think about what we call our x value. We've called it our independent variable. We've called it our domain. We've called it input. And it all means the same thing. Look at what we've called my y value. We've called the y value my dependent variable. We've called it the range. And we've called it output. And it all means the same thing. So when we look down here, and it says, given each function and domain, find the range values. So it's asking us to find the range. So first of all, we got to know what it's asking. It's asking us to find the y values. So here, it's giving us the domain, and now we want the range. Before, when we were given the domain, we found the range, but we graphed our results. Here, you got to look at what the question's asking. It's asking find the range of values. So just like they gave it to me domain as a set of ordered, as a bracket, more than one solution, that's how I'm going to give my answer. So when x is 4, so I'm going to evaluate the same way. When x is 4 minus 5 is negative 1. When x is 6, 6 minus 5 is 1. And when x is 8, 8 minus 5 is 3. So this is my range of values. So all I need to do, and when I'm answering this question, is I need to write it in range form. So I can put range. Remember how range is written. Least to greatest, numbers don't repeat. So negative 1, 1, 3. And that's my range. An easy way for you to do it is probably set it up as a table. So when x is 4, 6, 8, here's my range. Negative 1, 1, 3. So let's do that. Let's set up a table, and then when I give my range, least to greatest, numbers don't repeat. So let's take a look at number 9. So I'm going to set up my table. Here's x and here's y. And when x is negative 2, don't look what you got here. 2 negatives make positive. So 4 plus 2. So when x is negative 2, 3, 5, that's what I'm looking for. When x is negative 2, y is 6. When x is 3, 4 minus 3 is 1. When x is 5, 4 minus 5 is negative 1. So I filled up my table, and now I'm going to make my range. Remember, least to greatest numbers don't repeat. So that's my range. And that's how you're going to do them, for homework. So if you have a question, come and see me during tutoring, but make sure you understand it. Good luck.